Hi, welcome to the video on terminologies related to decision tree. By the end of this video, you will be able to define physical characteristics of a decision tree such as root node, leaf node, branches, etc. Now in the previous video, we learned how prediction works in decision trees. Now let's move ahead and quickly learn about the key terms associated with the decision tree. We will refer to this decision tree, which we have seen in the previous video as well, to explain different terminologies related to decision trees. The first one is what we call root node. A root node represents the entire population or data. A root node further gets divided into two or more sets. Next is splitting. It is a process of dividing a node into two or more subnodes. The highlighted lines here represent the splitting as a node is being split here into subnodes. When a subnode is further divided into subnodes, then the initial subnode is known as decision node. So here, these two highlighted nodes are the decision nodes. Now, the nodes which do not split further are known as leaf or terminal nodes. Here, these four nodes do not split further, and hence these are the terminal nodes. A subsection of the entire tree is known as a branch or a subtree. So in this example, there are the two branches or subtrees of our initial complete decision tree. Finally, we have parent and child nodes. A node which is divided into subnodes is called parent node of subnodes, whereas subnodes are the child of parent node. Let's say these are the names associated with each node, A, B, C, D and so on in our case. So, if you look at this particular section here, A is the parent node and B and C are the child node of A here. Similarly, here B is the parent node and D and E are its child nodes. And in this case, C is the parent node whereas F and G are its child nodes. There is one more terminology called the depth of the tree. It is the length of the longest path from the root till the leaf node. Note that the root node alone is considered as tree of zero depth. Here, the longest path is only 1 and hence the depth of this tree is 1. If you look at this particular problem, the longest path here is 2 and hence the depth of this tree is 2. Finally, the longest path in this tree is 3 and hence the depth is 3 here. Can you tell how many leaf or terminal nodes are there in this tree? Remember, the leaf nodes are the nodes which do not split further. Yes, this tree has 5 leaf nodes as highlighted in the image. These are some of the most common terminologies related to decision trees. In the next topic, we will look at some techniques that you can use to select the best split points in decision trees.